Dear friends, welcome to another video. Today we will learn about collisions in Pygame. We will recreate the scene on the screen, a dino sprite running into a square. Whenever the dino hits the square, its hitbox turns red. Let's jump right in. Let's create a new Python file and name it main.py. Now we have to create a simple game loop. If you don't know how to create a simple game loop, please watch my detailed video called Get Started in Pygame in 20 minutes. It will teach you everything you need to know. I will quickly create a new game loop now. First, let's import Pygame. Import Pygame. Now let's create the game window. Window is equal to pygame.display.setMode parentheses, again parentheses, 1200, 800. Let's set the caption for the window. Pygame.display.setCaption parentheses, quotes, Pygame collisions. Next, let's create a clock object. We are going to need it to set the target frame rate for our project. Clock is equal to pygame.time.clock. Now it is time for the game loop. While true, colon. In the game loop, the first thing we have to do is to check for events. Specifically, we need to check for the quit event, which occurs when the user presses the X button on the game window. For event in pygame.event.get parentheses and a colon, if event.type equals pygame.quit colon. If the user presses the X button on the game window, we have to close it. Pygame.quit parentheses and sys.exit parentheses. To use the sys.exit function, we need to import the sys module as well. So at the top of our file, we import it like this, sys here. Let's now paint the background of the window white. Window.fill parentheses, single quotes, white. Now we have to update the contents of the game window. Pygame.display.flip. And finally, let's set the refresh rate of the window to 60 frames per second. Clock.tick parentheses 60. Our game loop is ready. If we run the game now, we can see a window pops up with the color and the dimensions we defined. Cool. Let's now work on the dinosaur. We are going to use object-oriented programming to help us organize our code. We will create a dino class. This way, we will be able to reuse this code in future projects with minimal changes. So we will need to create a new file to create the dino class. I press Ctrl+N to create a new file and then Ctrl+S to save it as dino.py. Now we can create the class. Class dino colon. The next step is to create the init method. Def __init__ parentheses self colon. Now let's think about the attributes we are going to need. First of all, we are going to need an image. So let's load the image of the dinosaur. I have placed the image that we are going to use in this game in a folder named graphics inside our game folder. You can download all the files from the GitHub repository linked in the video description. So let's load an image from the graphics folder. Self.image is equal to pygame.image.load parentheses quotes graphics / dino.png. In this line, we load an image file named dino.png from the graphics directory, assuming it's in the same directory as your game script. This image will serve as the visual representation of our dinosaur in the project. We use the pygame.image.load function to load the image and then assign it to the image attribute. But to use this function, we need to import Pygame. So at the top of our file, let's import Pygame. Import Pygame. Next, we need to know the position where the dinosaur is on the screen. So let's create a position attribute of type vector2. In Pygame, vector2 is a data type representing a 2D point or vector with x and y components. It is exactly what we need to represent the position of the dinosaur. Self.position is equal to pygame.vector 2 parentheses. Let's place the top left corner of the dinosaur object at coordinates 100, 100 for start. So we type 100, 100. Now let's draw the dinosaur on the screen. Let's create a draw method. Def draw parentheses self colon. Now we are going to use the bleed method of the window object we have created in the main.py file method to draw the image on the game window. But our class cannot access that object, so we have to pass it in as an argument to the draw method. So we type window here. Now let's draw the image. Window.bleed parentheses self.image parentheses self.position.x self.position.y. This line draws the self.image at the coordinates specified by the self.position.x and self.position.y on the window surface. Now we are ready to see our dinosaur for the first time. Let's go back to the main file. Here is a quick shortcut. You can press Alt+1 and Sublime Text will get you back to the first open tab of your project. First, let's import the Dino class. From Dino, import Dino. With the class imported, we can now create a Dino object. Dino is equal to Dino. Now we can draw the dinosaur. In the game loop, after creating the background, we just have to call the draw method of the Dino object. Dino.draw parentheses window. If we run the game now, we can see the dinosaur for the first time. Beautiful. When we use the draw method, the dinosaur appears on the screen where we told it to be. We said that we want our dinosaur's top left corner to be at position 100, 100. That's why the dinosaur starts at the top left corner of the screen. Now let's make our dinosaur respond to the player's commands and move accordingly. Let's go to the dino.py file and create an update method. This method will be called at every frame, and it will be responsible for detecting key presses and moving the dino object. Def update parentheses self colon. We want to move the dinosaur every time the player presses any of the arrow keys on the keyboard. To move the object, we need to change the position of the object on the screen. So let's give the object a speed. Let's go back to the init method and add an attribute called speed and initialize it. Self.speed equals 10. Now it is time to go back to the update method. We need to detect when the user presses any key on the keyboard. Detecting a key press with Pygame is very easy. We do this with a call to the pygame.key.getPressed method at every frame, which returns a list of Boolean values representing the state of every key. If we detect that the user pressed the right arrow key, for example, we need to move the dinosaur to the right, which means we have to increase the x-coordinate of the dinosaur's position. Let's do it. Keys is equal to pygame.key.get_pressed. If keys brackets pygame.k_right colon self.position.x plus equals self.speed. In this code, pygame.kWrite corresponds to the right arrow key. When it is pressed, we increase the x-coordinate of the dinosaur's position by self.speed. We do the same for the left arrow key, but this time we will decrease the x-coordinate of the dinosaur. If keys brackets pygame.k_left self.position.x minus equals self.speed. This block of code moves the dinosaur to the left by decreasing its x-coordinate. Next, we handle the up and down arrow keys. Moving the dinosaur up requires decreasing the y-coordinate, since the origin 0, 0 is at the top left corner of the screen, and moving it down requires increasing the y-coordinate. If keys brackets pygame.k_up colon self.position.y minus equals self.speed. If keys brackets pygame.k_down colon self.position.y self.position.y plus equals self.speed. Now that our update method is ready, we can test our code. Let's go back to the main file and call the update method. Inside the game loop, before drawing anything on the screen, we type dino.update. This ensures that the dinosaur's position is updated based on the user input before we draw it on the screen. If we run the code now, we can see the dinosaur moves on the screen when we press the arrow keys on the keyboard. Beautiful. Next, let's create an obstacle for the dinosaur to collide with. We can create a rectangle to represent this obstacle. Outside of the game loop, we type obstacle is equal to pygame.rect parentheses 800, 200, 200, 175. This creates a rectangle positioned at 800, 200 with a width of 200 and height of 175 pixels. We will use this rectangle to check for collisions with the dinosaur. This rectangle will be placed on the screen as a static obstacle for the dino to collide with. Now let's draw this rectangle on the screen. We will use the pygame.draw.rect function in Pygame. Inside the game loop, before drawing the dinosaur, let's also draw the obstacle. Pygame.draw.rect parentheses window, black, obstacle, 5. This line of code draws the outline of the obstacle rectangle on the screen using the color black and a border thickness of 5 pixels. Let's run the code to see how it works. Perfect. As you can see, a rectangle has appeared on the screen. We can move the dinosaur around it, but nothing happens when they collide. Now we need to detect when the dinosaur collides with the rectangle. We can do this very easily. Pygame provides various functions to detect collisions. We will use the collideRect method, which returns true if two rectangles collide. This is exactly what we need. We have the rectangle of the obstacle and we need to check if it collides with the dinosaur. But the dinosaur object does not have a rectangle to use. That's what we have to do now. We will create a rectangle that has the exact same dimensions as the dinosaur image and it is positioned at the same place on the screen. The top left corner of this rectangle will correspond to the top left corner of the dino image. To do this, we will use the getRect method of the Pygame surface, which provides the width and height of the image. We will then set the position of this rectangle to match the dino's position. Let's open the dino.py file and add another method to our class that will return the rectangle of our object. Def get_rect parentheses self and a colon. We need to return a pygame.rect object. We will use the getRect method of the image attribute. The image.getRect method creates a PygameRect object with the same width and height as the image, which then can be used for positioning and collision detection. Return self.image.getRect. Now we just need to position it, so we will use self.positionX and self.positionY for the coordinates. Top left is equal to parentheses self.position.x, self.position.y. This line of code creates and returns a rectangle with the same width and height as the dinosaur image, positioned such that its top left corner is at the dinosaur's current position on the screen, using self.positionX and self.positionY for the coordinates. Our method is ready. Before we move on, let's draw this rectangle, which in game development is called a hitbox. A hitbox in game development is an invisible shape or area that represents the physical boundaries of a character, object, or entity on the screen. It is used for detecting collisions, allowing the game to determine when two objects interact or overlap. The hitbox doesn't always match the exact visual appearance of the object, but provides a simplified representation to make collision detection more efficient and responsive. In our case, the hitbox will be a rectangle that perfectly encloses the dino character's image. By drawing this rectangle, we can visualize where the dino's interactions occur, making it easier to debug and refine collision mechanics. To be able to see the hitbox, let's create a new method in our dino class. So, in the dino.py file, we add a new method. Def draw underscore hitbox parenthesis self, window, is underscore colliding, colon. The draw hitbox method accepts two arguments, window and is colliding boolean. The window argument is the Pygame surface where the hitbox will be drawn. This is typically the main game window. The is colliding argument is a boolean that indicates whether the dino character is currently in a collision state, true, or not, false. If is colliding is true, the hitbox is drawn in a color that visually indicates a collision is occurring, like red for example. If is colliding is false, the hitbox is drawn in a different color, for example black, to show that no collision is currently happening. This visual feedback helps us quickly and clearly see whether the dino's hitbox is interacting with an obstacle, making it easier to identify problems or refine the game's collision mechanics. Now let's implement the method. First, let's choose a color based on the collision state. Outline color is equal to quotes red if is colliding, else quotes black. If is colliding is true, we use a red color for the hitbox, else we use black color. Now we can draw the outline of the rectangle. Pygame.draw.rect parenthesis window, outline color, self.getRect, 3. Our method is ready. It uses the getRect method we created earlier and draws the outline of the rectangle it gets. Cool, let's try it out. In the main file, inside the game loop, after we draw the dino object, let's also draw the hitbox. Dino.drawHitbox parenthesis window, false. This method requires a boolean argument, which we will set to false for now. If we now run the game again, we can see a black hitbox appears. Very cool. Now, all we have to do is to check for a collision between the rectangle of the dinosaur and the obstacle rectangle. Let's do it. Inside the game loop, after updating the position of the dinosaur, let's check for collisions. Is colliding is equal to dino.getRect parenthesis dot collideRect parenthesis obstacle. With this line of code, we check if the rectangle that encloses the dino image is colliding with the obstacle, and we save the result in a boolean variable. If the two rectangles are colliding, the is colliding variable will be true. Now we can use this variable in the drawHitbox method. So instead of false, we pass is colliding here. Let's update our code and run it again. Perfect, our hitbox appears. And when the dinosaur is colliding with the obstacle, the hitbox turns red. Our collisions work. You can see that our collision system works whenever the dino hitbox overlaps with the obstacle. Let's make a small change to our code. Let's go to the dino.py file. Let's say we want to draw the hitbox only if we collide with an obstacle. So we delete this line of code and we enter another one. If is colliding, and in the next line we give the hitbox a red color. That's it. Let's test our changes. Perfect. As you can see, the hitbox now appears only if we collide with the obstacle. As you can see, simple collisions like this are straightforward to implement in Pygame. The dino class we have developed is versatile and can easily be reused in other projects. Its encapsulated structure means that its movement, hitbox drawing, and collision detection methods are all contained within the class, making it portable. If you are creating a platformer or another game where a character needs to interact with obstacles, we can quickly integrate the Dino class for smooth movement and accurate collision detection. I hope this video was useful. Thanks for watching, and I'll see you next time.